Okay, let's be real for a second. Have you ever been afraid of your own code? Come on, you know what I'm talking about. You open up a file you wrote like 6 months ago, and you have absolutely no clue what's going on. You think, I'll just make one tiny little change, and then boom, a whole chain reaction of bugs just explodes across the system. Yeah, we've all been there. But what if I told you there's a way to stop that from happening? Well, this is the first video in a 6-part series where we're going to do exactly that. We are diving deep into the solid principles, the 5 rules that really separate the good code from the truly great professional code.
So the legendary Kent Beck once wrote that the idea that good code matters is a fragile premise. Fragile? Man, I gotta disagree. I don't think it's fragile at all. In fact, it might be one of the most solid, battle-tested truths in our entire industry. And you know how we know it's true? Because every single one of us has felt that deep, soul-crushing pain of its opposite, bad code. We've all been stuck in a mess that turned what should have been an hour-long task into a week-long nightmare. So how does that even happen, you know? How does that clean, elegant code that we were so proud of just turn into this monster? Well, it doesn't just go bad. It rots. Seriously. Like a piece of fruit left out on the counter too long, software degrades over time. And this rot, it isn't invisible. It has specific symptoms, or as the pros call them, design smells.
Now, these design smells are basically the warning signs that our code's architecture is starting to fall apart. And learning to recognize them, well, that gives us the words to describe the pain we're feeling. But more importantly, it gives us a roadmap to start fixing it. Think of it like an early warning system for a project that's about to fly right off the rails.
Here are some of the big ones, laid out by the man himself, Robert C. Martin. You've got rigidity, fragility, immobility, and viscosity. Today, we're really just going to zero in on the first 2, mostly because they are the most common and honestly the most destructive signs that your design is in serious trouble.
So first up, rigidity. This is that feeling when you're asked to make a simple change, something that should take an hour, and it just cascades into this week-long ordeal, right? You touch one little module and suddenly 10 other modules that you didn't even look at just break. It feels like you're trying to sculpt with concrete instead of clay. The design is just fighting you every single step of the way, making every small tweak a massive, risky effort.
And then you've got its evil twin, fragility. This is that fear you get in the pit of your stomach when you have to modify your code. You make a change in, say, the billing module, and somehow, for some reason, the user login screen breaks. There is no logical connection between them, but it breaks anyway. A fragile system is basically a minefield where any step you take could be your last, and you're just constantly putting out fires in totally unrelated parts of the codebase. Okay, so to really see how these smells creep into a project, let's look at a classic cautionary tale. We'll call it the story of the copy program. It's a perfect example of how even the best intentions can lead to a design that just completely rots from the inside out. It always starts so simple, right? The project kicks off with a clear, simple request. Write a program to copy characters from a keyboard straight to a printer. The first version? It's perfect. It's clean, it's elegant, it does exactly what it's supposed to do. It's probably like 10 lines of code. Life is good, the developer is a hero. But then, a few months go by, and the boss comes back. Hey, great job on that copy program. Love it. But, you know, sometimes the users need to read from the old paper tape reader. And right there, you can just feel the developer's soul just cringe. Their beautiful, perfect little design was never made for some ancient paper tape reader. But hey, the boss insists. So what happens? The developer adds a little if statement. Maybe a flag, a switch, something small, a seemingly harmless change just to handle this one new requirement. And this, right here, my friends, this is the first step. This is how the rot begins. It's not some big, dramatic failure. It's a tiny little compromise that opens the door to total chaos down the line. So here's the crucial takeaway. Requirements are always changing. That is the one constant in our jobs. A professional developer just accepts this as fact. So if your design starts to degrade and rot because requirements are changing, the problem isn't the requirements. The problem is the design. Our software has to be built to survive those changes. So, what's the professional's response then? How do we build software that doesn't just survive change, but actually embraces it? How do we stop our code from rotting in the first place? Well, it turns out there's a blueprint for exactly this.
And that blueprint is SOLID. SOLID is an acronym for 5 foundational principles of object-oriented design. Now, these aren't some abstract academic ideas. Nope, they are the direct antidote to rigidity, fragility, and all those other design smells we talked about. These are the rules that allow us to build software that's flexible, understandable, and actually a joy to maintain over its entire life.
So, think of this next part as kind of like the movie trailer for this whole series. And to make it super simple, let's just imagine for a second we're not building software, we're building a wooden chair. SOLID is like the master craftsman's secret blueprint. It's a set of rules that make sure the chair is sturdy, easy to fix, and you can even add to it later without the whole thing just falling apart.
Using our chair analogy, it's pretty simple. S means a leg is just a leg. It's not also a cup holder. O means you can add a cushion without having to saw the chair in half and rebuild it. L means an armchair should work perfectly anywhere a normal chair would. I means you get just the chair you asked for. You're not forced to take the whole dining set with it. And D means the seat isn't permanently welded to the legs, so you can swap them out for cooler ones later. Look, if this way of thinking about code makes sense to you, do me a huge favor and hit that subscribe button right now, because in the rest of this series, we're going to unpack every single one of these principles with real, actual code examples.
Following these principles, well, that's what separates the amateur from the professional craftsman. It's the difference between building a rickety shack that falls apart at the first sign of a storm and building a masterpiece that can evolve and last for years and years.
Writing clean, solid code isn't about being some magical 10x developer. It's about care. It's about having the discipline to apply these proven principles every single day. And in the long run, this isn't just about saving your company money. It's a matter of professional survival.
So, I hope you're ready to dive in. Next time, we are tackling the big one, the single responsibility principle. We're going to see how one Swiss Army knife class, that class that tries to do everything, can completely and totally destroy your project's maintainability. Trust me, you do not want to miss it.
But before you go, drop me a comment below. Let me know. Which of these 5 principles are you most excited to master, and which one seems the most confusing right now? I'll be reading every single comment. And of course, don't forget to like, subscribe, and hit that little notification bell so you don't miss the next part of this series. I'll see you there.